Okay, so anyway, I think this will be the last lecture for your midterms. So everything that will be covered in this lecture will be included in your midterm exam, which is definitely any day this week. I'll be giving more instruction about this one. All right, so let's jump already to the continuation of our lecture. We are still under chapter 1, which is a lecture on groups and subgroups. So the last time we talked about what we mean by a group and a subgroup. So a group is simply just to have a review. A group is comprised of a set and a binary operation. We just defined before also what we mean by a binary operation. So the partnership of these two mathematical objects is such that it satisfies specifically three axioms. We have our associativity for the binary operation. We also have the existence of an identity element, and for all element of the given set, all elements have a corresponding inverse. And if these three axioms are satisfied, then that set, together with the indicated binary operation, forms a group. So normally, we denote a particular group generally by a capital letter G, unless we want to specify it because it's a specific name for a particular set. We also have discussed subgroups, and we emphasized before that a subset, just identifying a subset of a particular group, doesn't make it necessarily a subgroup, because again, a subgroup must, of course, it comes from a subset of a particular group, but it has to be a group itself, meaning it has to satisfy the axioms that we've set for a group. So how is that? How are we going to show that a subset is a subgroup? We have to make sure that the binary operation is again closed. I mean, the set is closed under the binary operation. And then, of course, the identity element of the group is also an element of the subgroup that we want, that the candidate for a subgroup. And also, for all elements of the subset, it has a corresponding inverse, which is, of course, element of the subset also. So it is a subgroup. From that standpoint, we will continue our lecture. So this time, we're going to discuss how to generate subgroups from a group, given a group. Although we've given a very traditional or a very manual, our approach before was very manual. What we did is to provide all the possible subsets of a given group, and then eliminate which of the subsets cannot be a group based on our criteria, as I mentioned a while back. Now, I'm going to give you another way on how to generate a subgroup of a given group, and that is by using this particular theorem that you can see here. It's theorem 1.7. By the way, I started naming our theorems just for the sake of organization. So in the previous slides, I actually edited and provided a numbering system for all the theorems we've discussed previously. Anyway, this is theorem 1.7. We let G, again, G is a general notation for a group. Let that be a group, and let A, also A, be an element of the group G. Then the subgroup H is the subset H equal to the set comprising A sub n, or A raised to n, where n is an element of the set of integers. That is a subgroup of G, and is the smallest subgroup of G that contains A. That is, every subgroup containing A contains H. Let us try to understand what this theorem saying to us. Now, this is, what is this? What is this set? A sub n. Of course, we need to clear our mind, no, from our traditional perception of a number raised to a particular number. Baka ang isipin natin, this is the ordinary exponential expression, a sub n. No, it doesn't necessarily mean that way. Because again, depending on the definition of the binary operation used in a group, then a raised to n would differ. Ang a raised to n, halimbawa no, a squared. What is a squared? Ang ibig sabihin ng a squared ay a star a. A star a. At kung ang binary operation mo doon ay addition, a star a or a squared is actually the same as a plus a because that's just the usual addition. The binary operation is a plus a. I mean addition, usual addition. If it's the usual multiplication, then a squared would mean a times a, and that is the same as a squared, the usual expression that we know, what which is a squared. We are squaring a particular number. If our binary operation is addition modulo n, then a squared is equal to the remainder when a plus a is added. So you see, a raised to n is a general term. Depending on the definition of the binary operation attached to set, the given set, then kailangan alam nating mag-adjust kung ano yung a raised to n. So anong ibig sabihin ng a cube under addition modulo n? A cube means a star a. I mean a star a. So first, you add a to itself modulo n, kung ano man yung divisor natin. And then you add it again to itself and then modulo n ulit. So iyon yung ibig sabihin ng a raised to n na nakikita natin dito. This is addition modulo. This is the set. And of course, we know that the binary operation here, we do not normally provide it here because it's supposed to be the reason why we are using this notation. So this is a group. We should know that the operation here is addition modulo 4. So even if it's not indicated here, it's the symbol used here is that's Zalem sub 4. So meaning this is the set containing all the possible remainders when two numbers are divided by 4, or the remainder when two numbers are added and then divided by 4. Now, if this is the group under consideration, how are we going to generate a subgroup based on this theorem? Okay, so meron tayong group. This is the set. And again, as we mentioned, the operation here, the binary operation is the addition modulo 4. Our divisor is 4. Now, let us generate subgroups. Of course, we start from A. We choose an A from the given group. So, pwede tayo mag-start ng 0, and then 1, and then 2, and then 3. It will generate the subgroup. Let's start with the subgroup generated by the element 0. Okay. So, using this theorem, i-erase natin yung A, which is in this case 0, ng N. What is N? Any element of Z. Well, since 0 raised to 1 is just 0, this subgroup is simply the trivial subgroup, or the subgroup containing the identity element. So our identity element here is of course 0. How about, so of course there's no point of computing 0 squared because it will always give us 0 as an answer. 0 cubed. 0 plus 0 plus 0 is 0 divided by 4 gives us 0. How about the subgroup generated by the element 1? How do we do that? Let us start with a sub 1. A raised to 1. Why do I keep saying that? Let's start with 1 raised to 1. Well, we are under addition modulo 4, so that's simply 1. 1 squared, ano nang ibig sabihin nito ulit? It's actually, because the binary operation nga is the addition modulo 4, this means 1 plus 1 modulo 4, which is 2. 1 cube means 1 plus 1 plus 1 modulo 4. Actually, because it's a binary operation, we can enclose any of the, we can solve any of the 2 here. And then add it again to the third. The result there is 3. And then, raised to 4, that means 1 added to itself 4 times. Modulo 4, that will give us a, a remainder of 0 because 4 is perfectly divisible by 4. The remainder is 0. So that the subgroup created using this element 1 is the set 0, 1, 2, 3. So we are putting this one as a set. Yung result ng ginawa natin dito. 0, 1, 2, 3. And then simply arrange it. Let's continue by constructing the subgroup created by element 2, the element 2. So again, let's start with 2 raised to 1, that is 2. 2 squared means 2 plus 2. And that gives us 0 remainder. And then 2 cubed, that's 8. No, it's not. It's 6. Modulo 4 gives us a remainder of 2. And then 2 raised to 4, it will give us again 0. So if we're going to list all the answers, actually there are only two elements of our subgroup, 0 and 2. And then of course, the last subgroup, the subgroup generated by the element 3, we do the same, and we'll arrive at a set containing the entire elements of Z sub 4. So, what are the subgroups of a Z of this one? Under modulo 4, addition modulo 4, 1, 2, 3, 4 yan. Ito yung mga subgroups, yung mga set na ito. So you see, we did not, compared to our technique the last time, this is, of course, far easier to do. Instead of identifying all the subsets, tapos hahanapin natin kung alin sa subsets ang subgroup. Meaning, andyan na yung identity element, may inverse lahat, and all. Okay. Let's have another example. This time, our set is this. U of 15. Alam na natin kung ano to, no? This is, the binary operation here is the multiplication modulo n. So since it's U of 15, that's modulo 15. Again, ang elements ng U of n, that's the set containing all numbers that are relatively prime to 15. When we say relatively prime, yung GCD dapat ng mga elements, ng kahit anong elements dyan, with 15 is 1. GCD stands for the greatest common divisor. So, of course, 1 is included because the GCD of 1 in 15 is 1. Also, the GCD of 2 in 15 is 1. Hindi kasama dyan yung 3 kasi 3 and 15, their GCD is 3. Divisible ang 15 ng 3. So, yun yung basis natin kung paano natin nabuo yung U of 15. That's why, if you are only given the name of the set and not the elements, then at least you know how to generate the elements of the group para makita natin, ma-visualize natin yung mga elements. So, it's different with Z sub n, and that's when our binary operation is the addition modulo n. For addition modulo n, the set there is constructed or always starts from 0 and until n minus 1. Kompleto yun. Integers ang mga yun. Pero sa U sub n, depende yan. Alright. Anyway, we still have the same theorem here above. Our goal, this is our second example, is to generate all the subgroups. So it's the same concept. Of course, it would be a bit different because again, the binary operation here is different. So what is if we start with the subgroup generated by the first element 1, then we start with 1 raised to 1. And 1 raised to 1 is simply 1. That is again. So anyway, for any group, uh, there's always a trivial subgroup. That's the subgroup containing the identity element. And for multiplication modulo n, the identity element is always 1. Okay. So that is the first subgroup. How about the subgroup generated by the element 2? We start with 2 raised to 1. That's 2. 2 squared. Alright. Since this is multiplication, this means 2 times 2. Hindi kagaya kanina na 2 plus 2. So 2 times 2 is 4. Modulo 15 is still 4. 2 raised to 3 means 2 cubed, which is 8. Modulo 15, it's still 8. 2 raised to 4 is 16. And modulo 15, the remainder is 1. So we went back to the identity element, we can stop. If we continue 2 raised to 5, pwede naman, pero ang makukuha ulit natin ay any of the numbers 2, 4, 8. 2 raised to 5 is 32, right? And modulo 15, that will give us a remainder of 2. 2 raised to 6 is 64. Modulo 15 will give us a remainder of 4. Ayun. So, bumabalik tayo sa mga elements. That's why I stopped here. The subgroup generated by 4, that's 4 raised to 1, that's 4. 4 squared, that's 16. Ayan, nakuha ko ulit yung identity element. I can stop. How about another subgroup generated by 4? So, ang daming nating i-generate kasi ang daming element ang U of 15. So, I hope you get the point. Hindi ko na kailangan sigurong isa-isa yung bawat elements. Pare-parehas lang naman. Under the same binary operation yan. So, I'll just click para hindi masyado matagal. Ayan. Ayan. Ito na yung 13. Medyo malalaki ang mga to. 13 raised to 1 is equal to 13. 13 squared means yung square mismo kasi nasa multiplication tayo. Modulo 15, the answer is 4. 13 raised to 4. Ang ginawa ko dito, actually, I used a trick. Kasi, parang ang hirap kasi i-raise to 4 ang 13 ng masyadong malaking number yan. Tapos saka mo i-divide pa ng 15. And then you take the remainder. Why not use something that you have already computed? For example, 13 squared. Ang 13 squared, pag square mo ulit, that's 13 raised to 4, which is precisely what you want to compute dito sa fourth step. So, ibig sabihin, it's simply the square also of 4. And the 16, 4 squared is 16 modulo 15. Yan, mas madali na alam natin na 1. Yeah. That is supposed to be 13. Mali. Subgroup generated by 14. Okay. The subgroups of U of 15 under multiplication modulo 15 are 1, 2, 3, 4, 5, 6. Bakit 6 lang ang bilang ko dyan? Because if you notice, the subgroup generated by 2 is the same subgroup generated by 8. Ito. Itong set na ito at saka ito, parehas lang actually. So parang we cannot really say that there are two different subgroups. They're the same. 13 and 7. Subgroups generated by 13 and 7. They are also the same. 7? Asaan siya? Nawawala. Yeah, I think nawawala lang siya. Hindi siya nasama. Pero they're the same. 1, 2, 3, 4, 5, 6, 7, 8.
Sir, naulit yung sa 4, pero 7.
Sir, iba po ata yung number. Yeah.
Ito
Pati,
lang.
pati sa 13, sir.
Yes.
Dalawa po yung 13.
Edit na nga lang
Sir,
natin.
so pag naggaganito kami, dapat ang end up namin is yung identity niya po. Parang like, for example, 2, sana. Dapat yung module 2, yung end 2, parang ganun po.
What do you mean? Uh,
Eh,
yes.
yung end
Oo.
para po malaman yung elements.
Yes. So, depende siya kung ano yung identity kasi it's not always the case that the identity is 1. So, ang identity lang dito ng nataon na multiplication modulo 15. Kanina, ang identity element natin ay 0. So, we stop at 0. Kung nakuha natin yon, then we stop. Seven yun. 7 and 40.
Sir, hindi pa pwede itong gamitin dun sa activity 4?
No.
Oo nga sana, sir. Medyo marami.
Thank you,
I-use na
sir.
ano para ma-practice. Anyway, sige. Let's continue another example. This is actually another example. How about groups involving infinite sets. Halimbawa, the very usual group. The set here is the set of integers and the operation is binary, is the usual addition. How are we going to generate the subgroups? It's actually the same. So you just take an element A and then you compute for yun, A sub 1, A raised to 1, A raised to 2, ganun. Well, of course, yung A raised to 2, A raised to 3, under usual addition means A plus 3 plus 3 for A cube. Halimbawa. Or ang A raised to 5 dito sa usual addition ay A plus A plus A plus A plus A. Parang N times A, no? Let's start with the subgroup generated by 0. Well, 0 is an element of Z, so why not do that? And the set there is the set containing 0. This is, again, for the usual addition, the identity element is 0. This is a trivial subgroup. Sometimes we use this notation because very familiar or popular na group kasi talaga ito. Nagkakaroon sila ng mga special na treatment. Nagkakaroon sila ng mga names. So the subgroup generated by 0 in this group, given this group is like 0, Z. Ganyan. How about 1? 1 is an element of the set of integers. Therefore, we can use that to generate a subgroup of this group. So, if you imagine the set of integers, diba? From 0, 1, 2, 3 to the positive infinity and then negative 1, negative 2, negative 3 to the negative infinity, ang gagawin natin dyan ay, diba? I-multiply lang natin ang 1 sa lahat ng elements. So, yun yung ginawa natin. This is actually 1 times Z. And the result is this set. Actually, if you look at this set, it's just the same as Z. Tama? Nagkabaliktad lang yung hindi. It's exactly the same as the group. How about negative 1? Can we use negative 1 to generate a subgroup? Yes, using the same concept. Pero if we look at the resulting set, ganun pa rin. Although, if you look at this set, magbabaliktad nga lang. Andito naging positive yung nasa left, naging negative yung nasa right. But in a set, you can actually rearrange. Tama? It doesn't really matter the order ng mga elements ng isang set. Kaya okay lang yan. Kaya bumalik ulit, it's Z. It's the same as the original set. Let's use 2 as the generating element. Meaning, si 2 or 2Z i-multiply natin sa lahat ng elements ni set of integers. We will arrive at this particular set. This is simply the same set of even integers. Naging multiples lang siya ng 2. Nawala yung mga odd numbers. So we can continue actually. How about negative 2? It's the same. How about 3? How about negative 3? It's the same. We can actually generalize what is happening here. So in any n, so n is any a actually in the set. So the subgroup that will be generated is n z, that is the nth multiple, or meaning the set formed by multiplying n to all elements of the set of integers. Yeah, so it's still the concept is the same. Definition, we have here a definition 1.15, definition of a cyclic group. You've already seen this notation. This is how we named our subgroups a while back. Parang yung enclosure na yan, that is our symbol for a subgroup generated from a group. And A is the generating element. But anyway, let's read the entire definition here. Let G be a group and let A an element of the group G. The subgroup H, characterized in the previous theorem, is the cyclic subgroup of G generated by A and will be denoted by the following. So we are just trying to emphasize here the notation. So ang tawag doon ay cyclic subgroup because it's generated using an element A. And A is called the generator. Cyclic subgroup. Yan. So ito yung mga cyclic subgroup niya. These are the same pero dito mahaba kasi kaya kinuha ko yung general form. These are the 3 examples we discussed in the previous slides. Another definition, actually ang na-define kasi dito ay definition ng cyclic subgroup. And that's it. That's how we define a cyclic subgroup. How about a cyclic group? Kailan nagiging cyclic ang isang group? Not just a subgroup. An element A of a group G generates G and is a generator of G if this set is the same as G. A group G is cyclic if there is some element A in G that generates G. Ibig sabihin, cyclic ang isang group kung merong element doon na kapag kukunin mo yung laman niya, it is entirely the same as the group. So you could think of this subgroup as an improper subgroup. If you're going to generate the elements of this, it's the same as the element of the given group. So the group then becomes a cyclic group because there is a generator. It generates all the elements of the group. This is an example. The example a while back is a cyclic group under addition modulo 4, this set here. Because if we recall our example, of all the subgroups generated, there are actually 2 elements, 1 and 3, that generated the entire set, the entire group. Pag titignan natin yung subgroup na generated by 1, it's the same set, 0, 1, 2, 3, which is exactly the same as the group. Ganun din kay subgroup generated by 3. And for that reason, because these subgroups exist, then Z sub 4 under addition modulo 4 is considered or is an example of a cyclic group. In fact, meron tayong theorem mamaya pero nakalagay na dito. In fact, the set Z sub n, this is a general one and this is very important. So you pay attention to this one. This set for n element of the set of positive integers is a cyclic group under addition modulo n. Sinabi na niya, 1 and n minus 1 are generators. But it's not saying that these are the only generators. Depending on n, there may be other generators aside from this, and we will discover how. Kung paano natin malalaman yung generators. Again, without manually computing lahat-lahat ng subgroups. Actually, I mean, it's of longer solution yung ginawa natin sa ngayon. Later on, we will discover yung mga shortcuts by providing theorems and definitions. More theorems, more definitions, or corollaries. Okay, this is another example. We are still talking about cyclic group. This is our example kanina at nakuha natin yung mga subgroups. So, 1, 2, 3, 4, 5, 6. Ito yung lahat yung mga subgroups, unique subgroups na nakuha natin. Well, if you notice, U of 15 is 1, 2, 3, comprised of 1, 2, 3, 4, 5, 6, 7, 8 elements. Pero kung titignan natin lahat ng subgroup, parang ang pinakamataas yata yung ng number of elements. Di ba cardinality ang term natin sa set? 4. 4 lang yan. So, walang element ang nakapag-generate ng group natin. So, this is not a cyclic group. U of 15 is not a cyclic group. Wala siyang generator. Alright. Example 3. This is the decline for group. And I actually computed already the subgroups. Now the question is, do you think this is cyclic? Is this group cyclic? Yes or no? What do you think? Cyclic ba siya? Ito yung mga subgroups generated from each of the elements of the group. Still there? Hello? Are you still there? Diyan ba kayo?
Yes, sir, ay wait lang. Sir, pwedeng pa kwan sa example. Ay, hindi sir, ang sagot ko sana is non-cyclic kasi walang element ang nagbibigay ng apat.
Mhm. Yes,
Tabo.
that's exactly the answer. So the answer is no. That group, the decline for group is not a cyclic group. You know, obvious naman dito, no, dalawa or isa lang yung mga na-generate na elements. So, in a sense, in a way, there is no generator for them. How about this one?
Sir, cyclic.
If it's
Ay,
cyclic,
sorry.
ano yung
Tabo.
mga generators niya?
Sir, kasi ibibigay niya din lang lahat ng mga elements.
Which element? Which are the generators?
Sir, yung mga zero, ay, sir, yung -3, -2,
Generator ba
tama,
ang mga yon?
hindi po ba?
So a generator is an element from the set that generates all the elements of the set. So halimbawa no dito, balik tayo dun sa example natin na number. Oh, yan. This is a cyclic group because there exists a generator. In fact, there are two, 1 and 3. 1 and 3 are elements of the set and they are considered generators because when we construct the subgroups using these elements, it's just the same as the group itself. So 1 and 3, just as simple as that, 1 and 3 are generators of this set. So balik yan, ito, hindi kasi sila cyclic. So walang generator by definition. Pero ito, sabi mo, this is cyclic. Therefore, there should exist at least one generator. Which element or elements are the generators? So, ang set naman natin ay integers. So, dapat integers ang sagot. Integers ang generators. But which of them specifically? Well, ito, si 3, hindi siya pwedeng i-considered na generator. Kasi, pag titignan natin yung na-generate na set, it's not the same naman to the set of integers. Actually, ang set na ito, it's the set containing the multiples. Integers naman, pero kulang. Multiples lang of 3 ang mga ito kasi 3 ang generator natin. But if it's cyclic, as you mentioned, ano ang generator din natin?
Sir, will it be
1 at -1, sir?
and
Okay.
or
Yes.
n? Can we consider po yung sa n?
N is not a specific number, right?
Ah,
Parang
Yung
general
1,
form lang ito.
1 -1, sir.
Yes. Actually, there are two and only two generators for this group. If we trace, pag titignan natin ito, this is exactly the same set, no? The set of integers. So, na-generate niya ni 1. Actually, ganun din si -1. 0, obviously, this set is not the same as z. Itong 2, yung laman lang niya ay even integers nga. So, well, hindi siya parehas dito sa set of integers. So, yes, the generators are 1 and -1, and they are actually the only generators for this particular set. So, sometimes, in a cyclic group, sometimes may isa lang, sometimes dalawa, sometimes marami. Depende kung ano yung group na binigay. Alright. Order of a group versus order of an element. Definition tayo. What do we mean by order of a group? This is simply referring to the number of elements of the group. So sometimes finite, sometimes infinite, as the ones we use in our examples. We still use the absolute value notation to denote the order of G. So parang cardinality ito. However, since we are talking about groups and subgroups, parang hindi na siya akma. For cardinality, we only have sets. But this is not just a set, it's a group. It's a set partnered with a binary operation. So just to not be confused with other terminology, yan. We are using the word order. So order is simply the number of elements of a group. gamitin natin ulit yung example na ito. Yung example natin kanina, ilan yung laman yan? 0, 1, 2, 3 ang laman nito na set. So, 4 yung kanyang order kasi there are 4 elements. Dito, sa U of 12, bilangin natin 5. Kasi 5 yung laman niyan. So, ganun lang. The order of this group is infinite. Kasi yung set natin ay infinite. So, finite ang mga yan, infinite itong pangatlong example natin. So, that is what we mean by order of a group. Iba din ang ibig sabihin ng order of an element. Of an element, dapat yan. The order of A in a group G is the smallest positive integer n such that A raised to n is equal to E. If no such integer exists, we say that A has an infinite order. The order of an element A is denoted by, so remember yung subgroup natin ganyan lang. Pero kung ang tinutukoy mo ay yung order ng particular na element na yan, lagyan din natin ng absolute value function. So let's use the same examples para hindi masyadong maraming examples. I mean, confusing examples. Since this is the set generated by the element 0 and z sub 4, addition modulo 4 ulit tayo, yung order niya ng element 0 ay 1. Kasi 0 lang naman yung laman ng subgroup na to. How about this one, this subgroup? If we count 1, 2, 3, 4, kaya 4. So actually, your question a while back na should we stop when we have the identity element after computing yung A sub n? Actually, ito yung sagot, yes. Dito ang basis, ito yung basis ng pag-compute natin ng order. So we actually start with the element 1, 1 raised to 1, 1 raised to 2, 1 raised to 3, 1 raised to 4. We stopped here because we arrived already at the identity element. And that exponent is actually the same as the order. So that is one way, that is how we interpret actually the definition. Yun ang sinasabi ng definition. But this is actually the same as also the number of the elements of the subgroup generated by 1. How about 2? So 2 raised to 1 is 2 under addition modulo 4. 2 raised to 2 is 0. Since 0 is already the identity element in this particular group, I'm going to stop. And the order there is just 2. Ganun din, the order of the element 3 is 4. Alright, let's have this set. How about if we have this set? Ano yung order ng mga subgroups? Natapos natin kanina ito. Flash ko lang lahat. Ayan. So, 1 raised to 1, we already have the identity element. Kaya, 1 yung order ng element generated by 1. Dito, apat na beses tayo nag-evaluate para makuha natin yung identity element. So, the order is 4. Ito, 2. 4, 4, 2, 4 din at saka 2. How about if our group involves an infinite set? Of course, the order of any element will be at the same time an infinite one. Pag mag-add ka ng 1, ang generator natin halimbawa no ay na 1 kanina na siyang nasabi natin, 1 parang 1 plus 1 plus 1, kahit ilang 1 ang i-add mo dyan, hindi ka makakarating sa identity element na 0. That's why it's called infinite yung order ng particular na element na yun. Ganun din kay negative 1. Actually, ganun din sa lahat ng elements ng group na ito. All right, let's proceed to the subgroups of finite cyclic groups. Let's start with two theorems here. It says here that if G is a cyclic group with n elements and generated by A, let B an element of the same group and B equal to A raised to S, then B generates a cyclic subgroup of H. A cyclic group subgroup H of G containing n over D elements, where D is the greatest common divisor of n and S. Another theorem, let A be an element of order n in group and let K be a positive integer. Then, the subgroup A raised to K is the same subgroup generated by A raised to the GCD, greatest common divisor of n and K. Saan natin ba ito pwedeng gamitin? Yung unang theorem, it's actually telling us how we could compute the number of elements of a particular subgroup. Kanina ulit, when we were able to, when we computed for the subgroups, parang wala pa tayong idea kung saan tayo mag-stop to, kung ilang beses natin kailangang i-evaluate yung A raised to N para lang makarating sa identity element. By using this theorem, without even evaluating it, alam na natin kung ilan yung laman ng isang subgroup. Remember, we are talking about the number of elements. Ito, containing n over d elements, where d is the greatest common divisor of n and s. Consider again Z12. Not again, because this is a different example na pala. How many elements does the subgroups generated by 3 and the subgroup generated by 8 have? Kailangan ba nating evaluate yung 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4, 3 raised to 5, hanggang sa makuha natin yung identity element, which is again 0 kasi this is addition modulo n. No, the answer is no. We do not have to do that. Kung yung tinatanong lang naman ay number of elements, we can actually apply this theorem. N, saan galing tong n? N is the, so provided na cyclic group pala yan. Cyclic group ang tinutukoy natin. N is the number of elements of that particular cyclic group. So alam natin ang for Z sub 12, 12 yung laman din niya, yung set na ito. Kasi mag-start siya ng 0 hanggang 11. So, we know what our n is. N is 12. Our B, if we're going to make use of the notation of the definition, is 3. And GCD, because we need D. What is D? GCD of N and S, which is 3. And the answer is 3. GCD ng 12 at saka 3. The greatest common divisor, pinakamalaking integer na magdi-divide sa 12 at 3. Well, that's 3 itself. 3 divided by 3 is 1 and 12 divided by 3 is 4. Obviously, both of them are divisible by 3 and 3 is the largest nga na divisor. Now, how many elements does the subgroup generated by 3 have? So, i-divide lang natin yung n ng GCD na na-compute natin sa taas. So, 12 divided by 3, that's n divided by d equals 4. So, 4 yung elements. So, actually, if we compute for that particular subgroup, yung laman niya ay 0, 3, 6, 9. So, anyway, this is a cyclic group, but we are now sure that this one cannot be a generator. Even without looking at the particular result, with this information only, we know that this one is not a generator. Kasi 4 lang yung laman. Ang set natin ay 12 yung laman. How about 8? Yung isa. The answer is 3, yung nakuha natin na result, because the GCD of 12 and 8 is 4. So, n, which is still 12, divided by 4 is 3. Yung tatlo, yung 3 na ito, it's representing the number of elements of this subgroup. Again, this is not a generator. Just to verify, nilagay ko na dito yung actual na laman ng subgroup generated by A. Which is the set containing 0, 4, and yun yung gamit ng theorem 1.8. Yeah. Later on, I think it's in the next slide, yung theorem 1.8. But based from these two theorems, I'm going to present again another one, but this time it's a corollary. What do we mean by a corollary? These are same as theorem, but they are directly derived from a theorem. So in yung nasa taas, corollary. The first corollary, in a finite cyclic group, the order of an element divides the order of the group. I have another one, generator of finite cyclic group. So let the order of the subgroup A, subgroup generated by A equal to n. Then the subgroup generated by A is the same as the subgroup generated by A raised to j if and only if the GCD of n and j is 1. And the order of the subgroup generated by A is equal to the order of the subgroup generated by A raised to j even only if GCD is nj equal to 1. Now, anong ibig sabihin? How else do we term two numbers nj having a GCD of 1? Ano yung ibig sabihin nito? Definition kasi ito kaya kailangang formal. But what this mean is, n and j are relatively prime. Yun yung ibig sabihin nun. Relatively prime. Ibig sabihin, yung pinakamataas na divisor, na common divisor nila ay 1. Wala nang tataas pa doon. They are called relatively prime. Take note that two numbers that are relatively prime are not necessarily prime themselves. Halimbawa, 9 at saka 8. Actually, both of these numbers are neither prime, but they are still considered relatively prime because the greatest common divisor between 9 and 8 is 1. Yan. So, relatively prime. Yun yung ibig sabihin ng GCD of two numbers equal to 1. Anong gamit nito? Corollary 1.3 is significant if you are given a cyclic group and also you are given kahit isang generator. Using this corollary, we can use that one generator to compute for the other generators kung meron. So halimbawa, ang group natin na binigay ay U of 50. Ano yung laman ng U of 50? Ito yung set containing numbers, integers, starting from 1 that are relatively prime to 50. So, it's not 50, less than 50 yan, pero madami pa rin yan. It's like 1, 2 is not included, 3, is it included? Yan. Pero nakalagay na the subgroup generated by 3 is a generator. Now, how do we know the other generators and how many of them? Ano yung gagawin natin? Yung generator na yun, 3, raised to 1, it's siya mismo, 3. Pero i-raise natin, hindi dapat ganito. Saglit. Kapali yung notation ko. Dapat exponent yung isa. Okay. As I was saying, we can make use of this corollary to identify the other generators provided one generator. Yun lang nga lang yung condition, kailangan alam natin yung isa. So, kung completely wala tayong alam, at least our goal is to look for one generator, and then if we are able to identify one generator, using that we can identify all. In the case of U of 50, there are how many generators? 1, 2, 3, 4, 5, 6, 7, 8. There were 7 other generators, 8 including 3 itself. Now, how did we arrive at this? Yung sinasabi ng corollary natin, kailangan yung, kasi ang hinahanap natin dito ay actually ay J. Ito yung magsisilbing exponent natin. J and N, which is again, the number or the order of the group, yung mismong group, which is given in the problem. U of 50 contains 20 elements. It was mentioned here. So, our N here is 20. Now, if 3 is one of the generators, how can we compute for the other generators? Now, we need to think of numbers that are relatively prime to 20. So again, where did this come from? It's coming from the number of elements. Yung mismong order ni U of 50, itong 20 na ito. So alright, given those information, what is the next generator? Bakit walang 3 squared? Because 3 squared, the exponent is 2. GCD of 2 and 20 is not 1. They are not relatively prime. Kaya hindi siya nasama dito. Well, 3 is relatively prime with 20. Ganun din kay 7. So, na-skip si 4 at saka 5 at saka 6. Because 4, 5, and 6 are not relatively prime to 20. And then next is 3 raised to 9. By the way, we are under multiplication modulo 50. So, bakit napuntang 27 ang 3 cube? That is because 3 cube is 27 modulo 50. Kaya nakuha natin 27. 3 raised to 7 is a very big number. Tapos modulo 50 natin, ang remainder dyan ay 37. So, what are the values of J here? 3, 7, 9, 11, 13, 17, 19. Siyempre, 20 ang basehan natin kaya hindi pwedeng lumagpas or equal to 20. So, we stopped at 19. So, the generators are now 3, 27, 37, 33, 47, 23, 13, 17. So, anong na ulit yung ibig sabihin ng generator? These are the elements from the group that will generate the entire group. So kung ano man yung laman yan, hindi kasi natin makita. Sinabi lang yan na there are 20 elements, but we cannot see those 20 elements. But whatever those are, if we're going to generate them using 3, using 27, 37, until 17, they will all provide us the same 20 elements. Corollary 1.4. Generators of, this is now a specific corollary resulting from the theorems that we mentioned. Ito, nandito rin sa taas. For addition modulo N, the generators are easier to identify because it says here that an integer k and z sub n is a generator of z sub n, even only if GCD is of n and k is equal to 1. That's just saying na k is already a generator of addition modulo n if it's relatively prime to n. Halimbawa, z sub 30 yung group natin. Tapos tinatanong sa atin ang generators. How should we start? Madali lang. We can actually immediately identify all generators kasi the generators are simply the numbers starting from syempre, hindi na kasama yung 0. 0 will simply generate the trivial subgroup. So we start with 1. 1 is always relatively prime to any other number. So 1, we skip 2, we skip 3, 4, 5, 6. Well, syempre, basta even number yan, hindi na siya pwedeng relatively prime because alam natin na 2 can divide both numbers. Ang sumunod dyan ay 11. So, these are all the numbers that are relatively prime to 30. We stop at 29 kasi malamang hindi na tayo pwedeng lumagpas or equal to 30. These are the generators. 1, 2, 3, 4, 5, 6, 7, 8. So, you see, we were able to save parang 8 times na computation natin because we know that they are generators. The elements are just the same with the elements of Z sub 30. Yung kukunin na lang natin, yung evaluate na lang natin ay yung mga proper subgroups, meaning subgroups whose order is less than the order of the group itself. Yung mas konti yung elements niya. Yun yung ibig sabihin natin sa proper subgroup. Ibig sabihin, those are the elements generated by, well, of course, 0, 2, 3, 4, 5, 6, 8, mga ganon, hanggang 28. I think I have an example here. With all the theorems and corollaries that we mentioned, let us answer this one. So we find all the subgroups of Z18 and give the subgroup diagram. Subgroup diagram or the lattice diagram. Alright, so we can start with, since this is addition modulo n, we can start with corollary 1.4. Alam natin kung paano i-compute yung generators. The generators are, with respect to 18, numbers that are relatively prime to it are 1, 5, 7, 11, 17, and 13. This means the subgroups generated by this number are exactly the same as Z18. Ano yung laman ng Z18? This is the set containing numbers 0 until 17. Yeah. So, from Z18, parang i-cross out natin muna yung nandiyan kasi alam na natin yung mga subgroups generated by these elements. So it's time to generate now the elements generated by these ones. Yung mga hindi generators mismo ng group. Okay, so let's start with 2. I-generate natin ng 2 manually. So alam natin kung paano mag-generate ng subgroup using an element 2. 2 raised to 1, 2 raised to 2, 2 raised to 3, ganyan. Meaning, 2 plus 2, 2 plus 2 plus 2, 2 plus 2 plus 2 plus 2, modulo 18. Ngayon, kung gagawin natin yan, we would arrive at the set as shown in this slide. 0, 2, 4, 6, 8, 10, 12, 14, 16. Now, using theorem 1.9, backwards, ito yung theorem 1.9, ito yung equation. It says here that a subgroup generated by A raised to K is the same as a subgroup generated by A raised to the GCD of N and K. Now, bakit 2? Parang bakit kasi backwards? Why did I term it backwards? Kasi we will take this element, yung A na ito na alam natin yung value to be the GCD already. We are looking for K. We are looking for K. So, meaning, K is a number such that their GCD together with 18 would be equal to 2. So, I hope you get that. So, ano yung ipapartner natin kay 18 para 2 yung kanyang GCD? We start at 4. If you check it, 18 and 4, hindi naman pwedeng 4, no? 4 does not divide 18. Ganun din si 3. But 2 is a common divisor and actually the highest, the greatest divisor. So 4. 8 is also a candidate for K. So yung 4, 8, 10, 14 at saka 16 na yan, pare-parehas actually yung mga element nila. It's the same. Their elements, the subgroups generated by these ones, are the same elements generated by the subgroup generated by 2. So, at na-save natin yung effort natin by computing the subgroup generated by 4, 8, 10, at saka 14, at saka 16. So, i-cross out na natin sila from the list. Ganon din, continue by identifying the subgroup generated by 3. Yung hindi pa nabibigyan ng sagot ng subgroup. By manual computation, the subgroup generated by 3 is, how did we arrive at this? Ganon din, 3 raised to 1, 3 raised to 2, 3 raised to 3, hanggang sa makuha mo yung identity element. We see that the order is 1, 2, 3, 4, 5, 6. 6. So this is actually, yung 15, this is the same as 3 raised to 5. Tama? Kasi 5 times 3 is 15. Pagdating natin sa 3 raised to 6, that's 18. It will give us back the identity element na 0 because 18 is perfectly divisible by 18 itself. So, backwards ulit natin na gamitin natin yung theorem 1.9. Dapat ang GCD ng 18 at saka yung K natin ay 3. So, from among the numbers left here, sino sa kanila ang may GCD ng 3 kapag ipares kay 18? It's actually only 15. That's why the subgroup generated by 3 is the same subgroup generated by 15. So, cross out natin yung 3 at saka 15. I-generate natin din manually ang subgroup generated by the element 6. 1, 2, 3 yung laman. So, ang order ng element 6 ay 3. 12 paired with 18, their GCD is 6. That's why we conclude that the subgroup generated by 6 and 12 are just the same. And lastly, of course, kung i-cancel natin si 6 at saka 12, maiwan na si 9. Walang problema kay 0 kasi alam natin yan. Yan. So lastly, yung subgroup generated by 9 is just the set containing 0 and 9. 9 raised to 1 is 9. 9 raised to 2 is 9 plus 9, which is 18. Modulo 18 is 0. It went back to the identity element. Kaya ang kaniyang order ay 2. We know that this is the identity element, so the subgroup generated by the identity element is the trivial subgroup, a set containing the identity element mismo. So napakita natin lahat ng subgroups na ito without much of the manual computations as we did before. Now, in the instruction, we are also asked to provide the lattice diagram. So again, for a lattice diagram, we always start with, of course, the group mismo. And pababa tayo with the lowest order. Yan. So, ganyan. Yung order mismo. I mean, the group mismo. And then 2. And then 3. And then 6. And then 9. And then 0. Siyempre, pinakamababa ito kasi ito yung trivial subgroup. Ngayon, bakit sila lang yung nandito sa ating lattice diagram? Actually, there are a lot of subgroups, di ba? Kasi ang elements ng Z sub 18 ay 18, 0, 1, 2, 3 hanggang 17. Pero bakit 1, 2, 3, 4, 5, 6 lang yung naka-represent sa ating lattice diagram? Because we do not have to write all kapag pare-parehas yung subgroups. Remember that the subgroup 2 is just the same as we mentioned kanina as start tayo dito sa pinakamataas. The subgroup generated by 1, sabi natin is Z18. That's why they are equated here. Pero bakit wala ang 5, 7, 11, 13, and 17? Because they are already represented by the subgroup generated by 1. Yes. In a lattice diagram, isa lang. So we can actually make use of 5, 7, 11, 13, 17, but normally we use the lowest number. So actually nandyan, by spirit, ang subgroup generated by 5, 7, 11, 13, 17. Redundant kung ilalagay pa kasi natin. Actually, redundant na yan eh. Yan. This is the group. 1 is the generator. And then, sumunod na yung 2. O bakit wala din yung subgroup generated by 4, 8, 10, 14, 16? Eh kasi nga parehas sila sa subgroup generated by ilan ba yung order dito? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Yeah. So pababa tayo from left to right. If you notice from left to right, medyo angat yata ito ng konti lang. And then, of course, yung generated by 3, hindi naka-reflect yung 15 kasi parehas sila kay subgroup na generate ni 3. 6 ay nasa mas mababa kasi 3 yung kanyang order. Mas mababa din yung 9 from left to right, dalawa. And then, the lowest is the trivial subgroup. Alright. Anong sinasabi niya dito? Yes, from the corollary, yes, na nauna, nasa last slide, previous slide, the order of a subgroup divides the order of the group. Dapat divisible yung order ng mga subgroups natin or divisible yung order ng group natin by the order of the subgroups. If it's not the case, then you have to go back kasi may error ka dyan. That is already a theorem, so it should stand. Halimbawa, yung mga proper subgroups natin. Well, of course, yung generator, alam natin na parehas sila ng order with the group. 18 din. 18 divides 18, divides itself. How about the order of the subgroups? 9, 6, 3, 2, 1. Lahat ng numbers na ito, 9, does it divides 18? Yes. 6, does it divides 18? Yes, the answer is 3. Also, 3 divides 18. 18 divided by 3 is 6. 18 divided by 2 is 9. So, 2 divides 18. And, of course, 1 divides any number. Now, we are almost done. Let's have this one. Fundamental theorem of cyclic group. These are one of the most important theorems that will be presented to you this afternoon. What does it say? A subgroup of a cyclic group is cyclic. Moreover, the order of the subgroup generated by A, if pala, that's an if statement. If the order of the subgroup generated by A is n, then the order of any subgroup of subgroup generated by A is a divisor of n. And for each positive divisor, K of n, that group generated by A has exactly one subgroup of order K, namely A raised to n over K. Anong ibig sabihin nito? This theorem means that if a group G has an order n, then the subgroup generated by this A raised to a particular exponent is from the quotient of n and k, that is a unique subgroup of order k. Anong importance nito? So that maiwasan natin yung mag-compute ng mga subgroups na pare-parehas lang pala. Katulad ng nangyari kanina. Hindi naman natin yon ni-reflect yung mga hindi natin ni-reflect nung sa lattice diagram natin kanina, just to avoid that. Corollary of the theorem, specific to Zn, addition modulo n, for each positive divisor K of n, that set is a unique subgroup of Z of n of order k. So this is a specific version of the theorem. It's only talking about Z of n. Moreover, these are the only subgroups of Z of n. So this is actually yung gagamitin na ninyo to the activity na ibibigay. List all the unique subgroups of Z30. Are we going to identify all the possible subsets? Sobrang dami nun. Kasi there will be 30 elements of Z of 30 and then individually this exclude if it doesn't satisfy the requirements of a group. No. We use all the theorems that we presented today to answer this one. So how should we continue? Well, this is under addition modulo n, specifically addition modulo 30. So our n here is 30. So let's use corollary 1.5 to answer this one. From 30, we're going to list all the values of k, the possible values of k. K is anything, any number that divides n. So ano yung mga number na magdi-divide ng 30? Well, of course, the answer there is itself. We can start with itself. So 30 divided by 30 is equal to 1. That's n over k if k is 30. So that the subgroup generated by that is 0, 1, 2 until 29. Is this a generator 2? Generator ba ito? Yes, because 1 is relatively prime to 30. Next. So ano yung ginagawa natin dito? We are listing the unique subgroups. We are not identifying, no, but we can actually do at the same time, do the same. We are going to identify if it's a hindi. We're going to identify the unique subgroup muna and then identify further if it is a generator. So what is the next unique subgroup? What is the next number that divides 30 aside from itself? So let's let k equal to 15. Yun yung susunod na number na magdi-divide kay 30. So that n over k is 2. So yung result na yan, yun yung gagamitin natin that to generate a subgroup. The subgroup generated by 2 under addition modulo 30 is the set 0, 2, 4 until 28. These are the even numbers. And the order, by the way, is 15. Because according to the corollary, k is the order mismo. Kung ano yung k natin dyan, k is a number that divides n, that is already the order. Next value of k, a number that divides 30 is 10 because 30 divided by 10 is 3 obviously. So ang 3 na ito yun yung gagamitin natin as a the generator. The order is 10. So these are actually numbers, multiples of 3, 0, 3, 6, and hanggang sa 27. Next divisor is 6. N over k is 5. So from base 5, i-generate natin yung subgroup. And exactly, this is the set containing 0, 5, 10, 15, 20. So 6 dapat yung kanyang order because k is 6. Kung bilangin natin yung elements, 1, 2, 3, 4, 5, bakit 5 lang? 1, 2, 3, 4, 5. May mali ba? 0, of course, kailangan may identity element. 5 raised to 1. 5 squared is 25. Modulo. So, mali, no? Mali nga. Let's edit it. So, ano dapat? 5 raised to 1 is 5. 5 raised to 2 is 5 plus 5. It's 10. Tama naman. 5 cube is 5 plus 5 plus 5, 15. Raised to 4 is 20. Raised to 5. Raised to 5 is 25. Yan, kulang lang siya ng 20. Addition modulo tayo Kaya yung raise na yan, addition. Yung 6 cube, for example, is 6 plus 6 plus 6. Modulo 30. Balikan natin. Ayan. K is, anong susunod? K is 5. Because 5 is the next number that divides 30. Ang na-compute natin na n over k ay 6. This is the number of, this is the generator. Yung generating element mismo. And we check that 1, 2, 3, 4, 5 ang order ng subgroup na ito. 3, it's the same. 2 divides 30 obviously. And of course, 1 divides 30. So ano yung mga ito? Ito yung mga unique subgroups. 1, 2, 3, 4, 5, 6, 7, 8. Ang Z sub 30 ay merong 30 elements. Nasaan yung mga iba pa? Ang ibig sabihin nun, subgroups naman sila, kaya lang, it's a repetition, it's a redundancy from any of these. So yung nilist lang natin ay yung mga unique subgroups. And that's actually what we need. Because, as I mentioned a while back, if we go back to our previous example, parang wala nang silbi yung mga repetitions, no? Naka-equal sign lang ang mga yon. Alright. So, how many generators? Z of 30 yan. So, among the unique subgroups, ano yung mga generators? Among 1, 2, 3, 5, 6, 10, 15, and 30. Ang piliin natin ay yung mga relatively prime to 30. So, 1 is included. Is 2 relatively prime to 30? No. How about 3? Hindi rin. How about 5? No. 6? Hindi rin. 10? Hindi. 15? So, mukhang isa lang. Si 1 lang ang generator. By the way, itong 30 na ito, it's the same as the subgroup generated by 0. Yes, that was the last slide pala. As usual, we have your activity. There are 3 problems here. The first one is to find all the subgroups of U of 9 and U of 12. Find the order of each subgroups. Then, identify further if... So, ang gagamitin natin dito ay manual. So, you start from... Of course, you need to list the elements muna dyan para makita nyo kung ilan mismo yung generators. I mean, yung mga elements na magbibigay ng mga subgroups. Number 2 is an application of the theorem that we discussed in the latter part. Ganun din sa number 3.